Hello. All right. Let's get started. So first of all, I would like to apologize the length of my topic, but to my defense, I can say that I didn't even write that topic. And actually, now is maybe a good time to admit that I didn't even write the application to talk at Disobey. Someone else did. So what I'm today going to talk about is about using large language models, ChatGPT, in context of social engineering. So a little bit about myself. My name is Pyry Åvist. I'm one of the co-founders and chief technology officers at Hoxhunt. So to get a little bit context where this data and the kind of stuff I'm going to present comes from, Hoxhunt helps large companies, medium-sized, smaller companies to reduce human risk. And part of that is sending large amount of phishing emails to end users globally, from tens of thousands to hundreds of thousands per day. And that gives us a tool to test different ideas. A couple of acknowledgements before I continue. So first of all, a lot of people helped me in kind of making this experiment presentation real. So first of all, big thanks to our amazing offensive red team and some of the developers and product analysts who helped me kind of getting this done. So agenda. First, we're going to talk about, okay, what is this fuss about regarding ChatGPT, AI in terms of cybersecurity. Then we're going to a little bit talk about how do they work. So I'm sure many of in the audience knows this probably better than I do, but still we're going to get some kind of idea how these kind of models work, how do you train them, what do they actually do. And then we're going to kind of talk about the experiment, what was the setup for our experiment, and results. And then, okay, so what? What does this mean? What should we kind of use this information for? So what is this fuss about? So our customers, as soon as ChatGPT came out, our customers started asking us that, hey, how does this change kind of the landscape of social engineering? Will the attacks change radically? Will adversaries start using ChatGPT to actually send attacks? How should we prepare? And for us, we kind of thought, okay, there's fear and doubt in this kind of within our customers and our users, so let's test it out. Let's do an experiment. Let's see how the AI fares against the human in task of creating phishing attacks. So very briefly, how does a large language model work? So I'm sure you all read the amazing hacker creed that is actually mentioned on Disobey website. You have a sentence in here. You can create art and beauty on a, and then blank. So of course, all of you can actually think some kind of a continuation there. And the kind of hint in the hacker creed, it's a computer. And basically, the large language models, which are, from a mathematical point, very simple, what they are able to do is take this kind of set of tokens, a list of tokens, words, and predict what could come next. And they can give you kind of one prediction, but actually multiple and probabilities. What is the likelihood of a certain word? So this is, for example, output for this sentence using GPT 2.5, which isn't the latest and the greatest, but still quite formidable model. So you can see the most probable word is you can create art and beauty on a computer, on a whim, daily, on a budget, and of course, on a canvas. And if you plot the 100 most probable words, you get something like this. It's in a logarithmic format, so actually the probabilities drop quite significantly, quite fast. And the thing here is that all of you have seen some examples how abstract questions ChatGPT can answer, how abstract things it can perform. And at least I was amazed. And you kind of think that we have this notion that human language and human nature is unpredictable and complex. But if you really start to think about it, like, do you use the same words? Do you use the same sentences? Do you kind of like, if you have a sentence, do you use the same sentence next? At least I do. So you kind of like can imagine that if you have the capability, meaning the money, meaning kind of the compute power, meaning the energy to scrape the entire text, what is available publicly on the internet, and actually use that to train this kind of model, you're able to create something that is kind of very effective on mimicking humans. So then you take this model and you run it over and over again. And you kind of like ask it, what is the next word based on the previous input? And here lies, of course, a lot of the kind of fine-tuning you need to do. So, of course, you could always select the most probable next word, but that would be pretty boring. It would be basically kind of always output the same text. So here you need to like insert randomness and do kind of certain selections. So here, just a single run for the model. It decided to kind of come up with, you can create art and beauty on a computer and build your own. So what that is, we don't know. Of course, you can use this for other things as well. Human natural language, and of course, programming languages, which are, in a way, just an extension of kind of like a way for us to code our intent into something that we can kind of give to a computer, turn it into silicon. So here are a couple examples. On the left side, your kind of standard kind of snippet from C, and like the continuation, what the model thinks. And on the right side, kind of example of composing a SQL sentence. And of course, this will open up super interesting opportunities and also kind of challenges. So especially on the right example, I don't think there might be something wrong with that. And I'm sure when you like scrape the internet for all the code there is, feed that into a model, you will actually kind of get something that kind of might have interesting problems, let's say that, and kind of challenges for us as a community to solve. So that was how the model works. So it's a tool to kind of like, we think it's kind of, at least I thought it was like kind of impossible to do this task, but when you think about at the scale and at the magnitude level, unfortunately, humans are quite predictable. And that's the interesting development here, to me at least. So the experiment, we wanted to pit our amazing kind of red team against the AI and see how a team who has built thousands of phishing attacks, executed millions of simulations. They know how to build hard phishing attacks. They know how to build easy phishing attacks. How that will perform against ChatGPT in a kind of task of getting people to click links which they shouldn't. And this was the kind of the experiment we did. And this is the setup. So first we took kind of like, we took this amazing team and we put them into a dark room and closed the door. And it's actually the same room they every day work. Strange bunch of people. We have bigger and better rooms, but they decide to work in that room for some reason. And we asked them that, hey, could you create first a prompt, an idea of an attack, phishing attack you think would be relatively hard? And then create an attack of it. And then we took the same prompt and we fed this into an AI and asked the AI to create attack as well. And then we took these two attacks, put that into our engine, and basically then it started phishing our end users and we could start getting data out of like, okay, how well does the human team with experience, several years of experience, perform against the AI? And the kind of question like, what is a hard phishing attack? There's a lot of nuance in that. How I would like the kind of simplest way describe it is that a good phishing attack which converts people is like a good lie. More truth there is, more probable you're to kind of believe the one hook in the kind of lie. So more contextual, more relevant it is to you at this time, more likely you're going to believe it. More emotions it evokes in you, more scared you get, more likely you're going to just do something and kind of don't think about it. So that's one thing. But of course, you see quite a lot of very naive attacks as well in your Gmail or in your work email. But the attackers, the adversaries, they are not stupid. Far from it. Actually, for them, this is a business. And a business always presents a funnel where you take something in and you convert those through steps. So the attackers knows that if a person falls for a naive attack, they're most likely convert the next step. So for them, it's actually an optimization technique because they need to use resources if it's a money scam, etc. So it's better to get the more gullible people in. So what is hard, what is good phishing attack really depends what you're trying to achieve. So here's an example, one of the attacks, one of the prompts. So the prompt is create an email to contact a person working at Acme Incorporated, explaining that they might have accidentally scratched my car at parking lot, and so on. So here's an example what our human team created. It's an email from Jack Falk to me, kind of contacting me that I have actually kind of scratched potentially someone's cars at the parking lot. And kind of you can check the pictures here if it's my car. And here's the AI version of it. Pretty similar, some changes there. You can already spot changes in the language it's using, but still kind of like it goes to the point. So in total, we did 4 simulation pairs, 4 by humans, and then 4 corresponding by AI. All were in English, very simple text-based attacks. We didn't want to, at this stage, test visual effects, etc. Kind of keep it simple and kind of see how these very, very simple attacks works and make it data a little bit more comparable. In total, in this experience, we sent quite a small amount, over 53,000 simulations. The exercise is still ongoing. Our users are still receiving some of these. But at the time when I did the data extract, this was the amount. And we had users from over 100 countries. So quite a good kind of set of people. And I'll share some country results at the end as well. So then results. I'm not sure if I can get some drum roll here, but first let's look at the AI. So the AI, in average, over all of those simulations, achieved a failure rate of 2.9%. So out of the 1,000 emails or to 1,000 users we sent the attack, close to 3% clicked the link, converted to next phase. And we had a reporting rate of 86.5%. And for me, working in kind of the business of behavior change, this is much more important than the failure rate. Failure is about failure. Reporting is about defense. So more people actually report, those who spot the attack, report the attack, they can actually protect the other ones who failed, the 3% who failed. So these are pretty good numbers. And then if we look at our humans, our very experienced team, the results were this. So 4.2% failure rate and reporting rate of 85.1%. So our experienced team who has done this for several years, was actually better at this stage on creating attacks than the AI. So there was a clear difference. Of course, the reporting rate was also a little bit smaller because, of course, you have more people falling for the attack, more people actually not detecting that, hey, this isn't a real, your car hasn't been scratched, actually. This isn't a real email. This is actually a phishing attack. Second interesting thing that we looked at is that how does user experience affect this? So we have a lot of users in our platform with varying backgrounds, from security to kind of HR, legal, sales, etc. And we have users who have been exposed to less phishing attacks, and we have users who have been exposed to more attacks. They have more experience. They have seen sophisticated spear phishing attacks, credential harvesters. They have seen it all. So if you look at the failure rate of the kind of how it goes down, the more the experience the user is, it's pretty similar for both of these. So we start in a very high number of like 15%. So like if you have really inexperienced users, 15% of them convert actually. And it goes down. The interesting bit actually here is that when you go to the more experienced users, the AI and the human start to converge together. And I don't know, but one hypothesis we have is that those users who are experienced and fall for these attacks, it kind of really hits them. Maybe they just drove to the parking lot and maybe they hit someone there. So it's like really kind of like, you know, someone would send you an email about like you bumped into me, or like, of course I did it, and you don't read it and you just click it. So then it doesn't really matter too much the email content. It's more about the context. If there's a person like who just drove to the parking lot, etc. So it works much more effectively. A little bit about the countries. So we had 100 countries. I picked several here. So sorted by the biggest failure rate, by kind of the human attacks. So Sweden had the kind of highest failure rate, 6.1%. Finland 2.6%, yay! And we won that match. And then followed by United States, UK, Norway, Finland, and Germany had the smallest. And the Finland actually we had the smallest one with the AI-based attacks. And of course, there's a couple of things you need to note. The attacks were in English, so I would assume kind of like of course, in US and UK, that's much more relevant to them. But in Sweden as well, they're most likely going to use English as a kind of language which they operate at work, versus Norway, Finland, and Germany. So I think that kind of tells the difference between these two cohorts of countries. And interestingly, kind of Germany also had the smallest difference between these two, so they were quite close together. So that was the experiment we did, and we are really happy that we kind of did this, that we kind of understand, okay, what these can do, and let's talk about what this could mean. So based on this, we can totally say that large language models can be used to craft phishing attacks. That's kind of obvious here. So you get not as big failure rates, not as effective attacks, but you do get attacks that convert humans and get them to click links. And that's something that wasn't possible maybe 8 months ago. And that's kind of really interesting. As said, currently an experienced human red team can create more effective attacks. That's for sure, as of now. Some of anecdotal analysis on the differences of the attacks, when we looked at them kind of side by side, is that we know that ChatGPT tended to create too formal text. It wasn't a text that could come from your colleague or from the IT department. It was maybe like too long. It wasn't to the point. Other thing was that our humans, as they know this business, they were much more aggressive the language was desperate when there was a call for desperation, and it was accusatory. So you're kind of like our red team went pretty much all in invoking motions and reactions in the users with this. And kind of the AI, as if someone has followed like the kind of the aggressive language Bing is kind of producing, etc., there is probably like a tendency for the developers to actually tone down the language. But I think these two things are something with proper prompt engineering you can easily overcome and get the AI to be, and the language model to be aggressive enough. And of course, it might be that some of these models will be eventually open source. So you can train them. You can use the models yourself and train them to a specific task. One other very interesting area which we are definitely looking is kind of how can you use these to create much more contextual attacks. So you feed some information about the target and potentially use these to create better translation, especially in the countries where kind of like the English isn't the kind of first language you speak. We all have seen maybe, at least in Finland, kind of poorly translated attacks. You can easily spot either from the language translation or the context that you don't have the kind of nuances there, that this is not a real text message from a police, etc., or a bank. So these tools can potentially give you a way to turn very broken English into a very good, let's say, Polish or Finnish, and get a much more effective attack. Second question is the cost. Of course, like training these models at the moment is only possible for the companies who have the money and the resource to scrape the entire internet. But I believe that will change. Right now, OpenAI has forced the hands of Google. It has forced the hands of Meta to react. They need to come up with kind of counters to this. One way Google actually, back in the day, countered AWS was to open source Kubernetes. So we might really actually see in future, if these models aren't too dangerous or deemed too dangerous, that one play is to open source it all to kind of make sure that the kind of competition. So these might become available to anyone. And then you can find on these. And whereas previously you would send same attack to 1,000 users, the adversary, and hope 3% convert, with this tool, you can actually create attack to everyone. So that's kind of really interesting, and that changes the landscape a little bit, what we have seen so far. But on the other hand, I feel that the current controls and countermeasures, this is the kind of good part, so fear not in my mind at the moment. So the current controls and countermeasures which we have are designed to actually kind of work in a human-to-human communication, detect attacks that a human creates. And what these models are trying to do, they're trying to kind of mimic human behavior. So the technical layer, the filtering solutions we have in place, and the behavior change programs we have in place, they actually work against this stuff. We, of course, need to kind of look at them, train them, make them better, but they actually kind of like, in my mind, you can adapt to them. So it isn't like a kind of fundamental shift that everyone should be panicking about this. So just kind of doing basically the things that you have done, if you have proper controls and defenses, will help you against this kind of wave if it's to happen. And like more experimenting is definitely needed. We're gonna definitely do a lot of experiments using AI. I'm already using it daily in my job. We're gonna make sure our red team kind of has full access to all of these models. They will use it to kind of see how better we can actually, what kind of failure rate we can get with a human-machine combination. What kind of reporting rate? How can we make our users more better at detecting this stuff? So we're going to continue experimenting. If you see me on the floor at some point, happy to discuss if you have some ideas how to use this. I'm kind of super excited to hear and discuss about it. And I'm kind of super excited to see maybe in 1 year what are other areas that these kind of models, how they change the cybersecurity, both for us as defenders, both for the adversary, and kind of seeing the talks maybe at the next year Disobey. And I believe there will be quite many regarding this. And there are so many interesting topics, from ethics to how do you reverse engineer these models to do your bidding, etc. That was my talk. We have a couple of minutes left, so if there are some burning questions, I'm happy to take them. So I guess we have a mic, so if there's questions, so put your hand up. There's a question. Yeah.
Hello. Have you considered running this experiment again by asking the OpenAI to reformat the letter into a more casual or more friendly format, so that would make the user more comfortable in reading it and understanding the subject, which was more seen in the red team generated messages?
Yeah. So to keep the test simple, we didn't do much of prompt engineering. We used the kind of like the prompt that the human wrote it, and basically the output of the model pretty much as it. So I totally agree. Just a little bit of like, you know, asking it to, hey, don't be so formal maybe, keep it a little bit shorter, be more aggressive, you could get better results. Fully agree.
Thanks for the talk. How would you describe the cost between these two approaches?
Can you say it louder? Cost?
Cost. How much did it cost?
Cost. Yeah, that's a good question. Well, kind of like we will have the salary discussions with the team later today after a few beers. But of course, if you have humans that you know, take quite long time to develop to a red team from birth to being like, well, I will say we have adult people working on this. So it's of course the cost for us with the AI, we could create this in 15 minutes. With our human team, they have several years of experience on this. So I would say kind of for us at the moment, the cost difference is radical. Of course, if you would account the kind of how much would it cost to create this model, then there's a kind of a tip for the human side. But I think this will become something that anyone can use, and it will not cost. It will be zero cost almost. All right. Thank you. And once again, if you have good ideas, just comment, take me from the sleeve. Happy to discuss anything regarding social engineering, AI, and have a great rest of Disobey.